Okay. Okay, good morning, or when you see this, hello DLs. Um, Sorry about this confusion, but right now we do not have internet access here at the school, and so we have to record. We still have to record these classes, but you just have to pick them up later. Um, so it's not live streaming; it's recorded streaming. Okay. Okay, guys, we're on lesson 120 of 21. That would be page 10 of your notes. Yes, we have.
We did notes Friday?
Yes.
You didn't do any of them? I don't remember. I don't remember any of them. Wait. Find my science notes.
All I can say is just keep looking for them right now. Okay. If you still can't find them, I'll get you another copy. But for right now, keep looking. Okay. And if you still can't find them, then just take the answers number wise and just put the answers down so you can copy them over later. Okay. John, no. Girls. Just a minute, DL's going to interrupt. Or fake live. Okay. We'll see how far we get. I don't want this. I want this one. Now who? Okay, sorry about that. Just was reading the text that I got. Okay, here we go. Let's do a little bit of review. What is the ability to predict what the weather will be like several days in the future? Forecasting. Okay. What are the 5 most important properties of air that meteorologists use for forecasting? Okay, there they are. Good job. What instrument is used by meteorologists to measure air temperatures? Okay. What type of thermometer uses the expansion or contraction of alcohol or liquid metal, mercury, in a thin tube to indicate the temperature? A liquid thermometer. Okay. Answers in the question. What type of thermometer is used to record the highest and the lowest temperatures of the day and night during a particular period? Maximum, minimum. Day and night. Okay. Highest, lowest. Okay. Maximum, minimum. Make the connection. What are the metal strips consisting of 2 thin strips of different metals bound together and are used to measure temperatures? Bimetallic strips. They're found in the thermostats. Okay. What records temperature changes over time? A what?
Thermograph.
A thermograph. What instrument measures the effective temperature on special electrical circuits? Electrical thermometers. Okay. You didn't know that there was such a thing, huh? What instrument is used to measure atmospheric pressure? Barometers. What is the oldest type of barometer consisting of a 3-foot long glass tube that was filled with mercury? Mercuriometer. There it is in the answer or in the question. What type of barometer uses a flexible, airtight metal box to measure changes in pressure? Aneroid barometer. What instrument records changes in air pressure over time? Barograph. On a barograph, what's the unit of pressure that is approximately equal to atmospheric pressure? A bar. Okay, just a bar. What are the units of measurement when changes of air pressure are not big enough to use a bar? Millibars. Okay. We're talking about still basic, the measuring basics. Today we're talking about number 3, the measuring of humidity. Okay. We're on page 10. Last Friday's homework was activity 9B. If you haven't finished that, get that in by 3 o'clock and you won't get a 0. I attempted to, as you can see, you got papers back, so I have grades down in my grade book, but I attempted to get those onto my schoolworks, and I was experiencing internet problems at my house, which is just less than a mile away, maybe a mile. So I don't know if it's the same problem that the school's having or not, but so the grades that you got on your papers today are not recorded on my schoolworks, or at least all of them. Some did get in before I went down, some, and then I just gave up and said I'll just do it tonight. Well, hopefully I can do it tonight. Okay. If not, I'll get them in. Just be patient, and when the internet allows us to go back, we will, and I'll get it done. Okay? So if you're wondering why things haven't changed, let your parents know that also, okay? Measuring humidity. We start with a hygrometer. This is an instrument. It's used to measure relative humidity. Okay? New glasses? Okay. Hygro means moisture. So a hygro, moisture, meter, measuring moisture. Okay? Humidity. There's some types of hygrometers. First of all, we start with a psychrometer. This is just a type of hygrometer that uses the cooling effect of evaporation to measure the humidity. Okay? Now, if you look at this, it's got kind of 2 on it. It's got the dry bulb thermometer, and it's got the wet bulb thermometer. And then there's a wick in there. That is, as it's doing it, or as you're using this, it's getting a comparison of the 2 all at once. Okay? So a psychrometer, the cooling effect of the evaporation. Second, you have a hair hygrometer. It's just, it's just using a strand of hair, okay, to measure the relative humidity. So if you were to pluck a hair, preferably a long hair, out of your head, you could use it in this hair hygrometer. Okay? Now, as you look at the screen here, it says a mechanical hygrometer uses hair or horse hairs. Okay? A lot of times it's the horsehair. That stretch as they absorb moisture. Okay? So, the longer the hair gets, the more humidity there is. Okay? So if you have a dry strand of hair, your relative humidity is going to be very low. But if you add water to it or whatever, and it stretches out, that means it's going to go down. And look how it's recording. It's recording it onto a bar graph, not a bar graph, but a barograph. There we go. Thank you. I knew it was on there someplace. Okay. I'm sorry. Interruption time. Going back to fake live. Okay. Now, so as it is getting the moisture, as it's absorbing the moisture, it's lowering it down. Okay, the strand is getting longer, so it's going to get this up and down motion on this barograph. Okay, and that's how they can determine the relative humidity over a period of time, by using this barograph system with the hair. Now, if the hair snaps, okay, and they don't have another one, then just probably connect the smaller parts together and it just gets a different type of a barograph. Or you go out and pluck another horsehair out of its tail and use it, or pluck somebody else's hair out of their head, okay, if you want to make your own, okay? Huh? Huh? Oh, gotta come back over here. Man, that hurt. It is. I don't know what I did, but man, it's tender too. Okay. Shh. Okay. Then we have the weather vanes. Okay. Now, if you want to be unique with this, a weather vane, let's put a definition, is just an instrument that indicates the direction of the wind by pointing into the wind. Okay? Okay? Now, if you want to get unique, okay, you could go sit on one of these poles up there on top of a building, and you could have your arms out representing the weather vane aspect, okay, and let the wind direct you, and then you could have a personalized weather vane, okay? Now, I was looking for some really unique ones, and right now this is right at the time, this is the one that I could only get, but you can get any type of weather vanes, okay? It's just something up there that is going to catch the wind and move it according to which direction it's coming from. Okay? Now, so this is how it is. Winds are named for the direction from which they come. I couldn't find a picture of a weather vane that gave me a direct look at the direction. But what do you think the direction of this wind is? South? Based upon your perspective, it could be. East-west or... Because the flag's pointing towards the S and the E. The E is actually behind the S. Yeah. Okay. So this one, by perspective of the picture, it could be S, could be south. It could be possibly east, based upon the perspective. I was looking at it more of like a southeast wind. Okay. To me, it's kind of more in between than it is anything. Okay. But this is what it is. It's the direction from which the wind is coming. Okay. Remember, we talked about the sea breeze, land breezes. We call them that because of where the wind's coming from. It's coming off the sea, it's coming off the land. Same way here. This is a wind coming out of the south, southeast. Okay, south, southeast, eastward wind. Okay? Now, on your notes, you have this scale. Numbers are different just a little bit, but the numbers on your notes is what your book had. I couldn't find one that had the exact, and I didn't want to retype all those. Okay, so I just took the scale, same scenario. You have the Buford number, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the wind speed, 0 is less than 1. For on one scale, it's 1 to 3 miles. 2 is 4 to 7. Now, like I said, they change a little bit on your scale on your notes, but this is the gist of it. So you can go across less than 1 for the wind speed in knots. It's a calm description. Okay. And you can generally tell this because I don't want to talk to you either. It's not Emily. Somebody from Laverne. So it's a scam. Okay, so you have in the dark blue, you have calm winds. Smoke is just rising to the top, going straight up. It's hardly even moving. Okay. You on the light blue, you have wind motion visible in the smoke. So it's kind of tapering off to one direction a little bit. On the light green, you have wind that's felt on exposed skin. Okay. Leaves rusty. Okay. But you have a light breeze. Now, looking at that palm tree out there, what do you think we have today? We have probably where we're at right now. A light breeze, if not in the number 1 category. Okay. The lime green or the dark green, gentle breeze, leaves and smaller twigs in constant motion. Okay. So they're constantly blowing around because we have wind speed of 8 to 12 miles per hour. A 4, dust, loose paper are raised, small branches begin to move. Okay. Wind speeds of 13 to 18 miles. And number 5, you have small trees begin to sway back and forth a little bit. Okay. It's a fresh breeze coming off probably the sea or the land based upon where it's coming from. And number 6 has a wind speed of 25 to 31. A strong breeze. Okay? Large branches are in motion. Whistling is heard in overhead wires. Umbrellas use is difficult because it wants to pull you away. That's a 25 to 31 mile an hour wind. Shh, guys. Number 7, you have a 32 to 38. A near gale. Whole trees in motion. Some difficulty experienced walking into the wind. Okay? You're at 32 to 38. Scale of 8, 39 to 46. You're in your gale winds. Twigs and small branches break from trees. Cars veer on the road. Okay? So you're driving along and all of a sudden you get this breeze and you veers off because of the push of the wind. So we're looking at 39 to 46 miles per hour. Numbers, scale of 9, 47 to 54. Okay? Larger branches break from trees. Light structural damage on buildings. A 10 scale, 52 to 63, 55 to 63. Okay? You have a storm that's developed. Trees broken, uprooted. Considerable structure damage on buildings. Shh. Scale of 11, 64 to 72. Wind speed or widespread damage to structure and vegetation. Then your 12 scale, plus 75. What happens at 75? You have a hurricane. Considerable and widespread damage to structures and vegetation. Violence of wind going on. So this is what they base it upon. Okay? They look at what's happening over on the right, and that kind of gives them an idea where they're at on the left. Okay? Then they got the other scales in there based upon where they're located at. So that's the Beaufort wind scale that's used to classify the wind speeds. Yes, sir. The direction from which they come. Okay. The anemometer. This is just an instrument that is used to measure the wind speed near the Earth's surface. Didn't put a picture on this because we have 2 types of anemometers that I wanted to picturize. And basically the definition fit both of them. So I just waited. Anemometer. Okay? There's 2 types of anemometers. First of all, you have your cup anemometer, consisting of rotating arms with cups at the ends. Okay? So, which one's the cup one? The one on the right. Oh, the one on the left? Yeah. Yeah. One on the left, because it has the cups. Okay? Or the arrow vane. That's the one that has the propellers at the end of the weather vane. Arrow, propellers, think of airplanes type of an effect. Okay? Cup anemometer, one with cups. Arrow vane, one with blades or propellers. Okay? Now, how do they record this? They're recording in this some precipitation that's going on. One way you can do this, you can be a meteorologist just by going to the store and purchasing one of these rain gauges. Okay? That when it rains, these will fill up based upon how much rain you're getting in an hour. Okay? rain gauge. Okay, so in the picture, how much rain what was received? 15. Okay, 15 centimeters. Okay, probably is centimeters at this point. Okay, okay. Not a whole lot of rain that's come down, but based upon the time frame, that may have been a lot for that one specific area. Then in the winter time, winter states, areas, probably even up the mountains here when it snows, they have what they call heated rain gauges. It works as the same as a rain gauge. The snow comes down, the snow fills up the gauge, and then they're heated, so they melt the snow to find out how much moisture there was in the snow. Obviously a lot bigger than the rain gauges. Okay. Okay, everybody with me? Now, when you are measuring things, okay, you need to take your instruments and make sure that you put them in locations where they can be read. Okay? Where they're not going to get the interference from obstacles around them. Okay? So in this picture, 4 to 1 is the distance from tall objects. 80 feet, basically, is where you're putting your rain gauges. And that's of a tree in this picture of 20 feet high. Okay? The best place probably is to put it is out on a mountaintop where there's hardly any distractions of it. And so they can get a clear picture of pure results of the wind. This is why the wind farm that's out east here, they put it in that valley where there's nothing blocking the wind. Okay, you got mountains on both sides, but which way is the wind usually blowing? It's usually blowing east to west for the most part, or it can go back west to east. Okay, and it's blowing right through this valley, right down through into that wind farm. And so there's no obstructions for those blades. So that they can get a true measurement of the wind and get as much energy produced as possible from those. Then you have this, a Stevenson screen. This is just a shelter that's having slatted sides and a slatted base to allow air to freely flow through the box-like shelter and reach the instruments inside. The instruments inside are your hygrometers and thermometers and rain, different types of gauges and so forth inside. That's all covered up by the picture on the right, okay, for protection. But it's getting the wind that's coming up. Now, why do you think that they're slatted down?
So rain can't go in.
Rain can't get in and destroy what's inside. Okay. Okay. It's a lot of it is basically for protection of the instruments inside. Okay, but yet giving it enough flow of air to get inside to get a good reading. A special shelter house with weather instruments. Stevenson screen. Okay, now we only have about 10 minutes left. I'm debating. Give me 1 second. Do I want to? Do I not? I think we're okay. We will go ahead and call it quits for today. A little bit early. Gives you about a little bit of time here that if you haven't worked on, or if you have some missing work that you need to get done, get it done, get it turned in. And so DL's cutting it short just a little bit. So hopefully we'll see you online tomorrow. Bye, guys.